Hello everyone, welcome to Standard 7 Physics class. In this video lecture we discuss about chapter 7 which deals with electricity and magnetism. So let us discuss law of magnetism. We know that magnet attracts substances like iron, nickel, cobalt towards it. This property of magnet is called magnetism. So the basic law of magnetism states that like pole of magnet repel each other while unlike poles of a magnet attract each other. Like pole means north pole of two different magnets and the south pole of two different magnets. When north pole of one magnet and the north pole of another magnet are brought closer to each other, they move away from each other. That is called this property of magnet is called like poles repel each other while unlike poles of magnet attract each other. It means if you bring closer to the north pole of a magnet and south pole of another magnet, then the get attracts these two poles gets attracted towards each other. So that is called unlike poles of a magnet attract each other. Unlike pole means one pole, south pole of one magnet and north pole of another magnet. These two poles are said to be unlike poles. Now test for a magnet. So we know that magnet attract iron and some other substances. Apart from this, it also attracts other magnets. So what do you conclude from it? Magnet attracts another magnet as well as magnetic substances like iron, nickel and cobalt. So how do we recognize whether a substance is magnet or not? Like poles of magnets always repel each other. This means that if an object is a magnet, it will repel the like pole of other magnet. Thus repulsion is definitely attributed to magnetism. It means that repulsion is the surest test for magnetism. Now let us discuss about electromagnetism. Electromagnetism is a process in which magnetic field is created by introducing electric current in a conductor. When current is passed through a conductor, it produces a magnetic field around the conductor, and the conductor behaves like a magnet. You see here, this is the switch, battery, connecting wire. This is an iron nail, which is coiled by insulated copper wire. Now, when the switch is closed, electric current starts flowing through the iron nail. When electric current passes through the iron nail, at that time iron nails behave like a magnet and attracted magnetic substances towards it. As long as the current passes through it, when you stop flowing the electric current through the iron nail, it loses the property of magnetism. So the magnetic effect of an electromagnet stays as long as the electric current passes through it. The magnetic effect of electromagnet can be increased by first increasing the number of turns of the coil. These are the number of turns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 turns of the coil. So first by increasing the number of turns of the coil, and second one by increasing the strength of the electric current flowing through the iron nail. So by two methods, the strength of electromagnet can be increased. First one is by increasing the number of turns of the coil, and second one is by increasing the strength of electric current flowing through it. Now we discuss about applications of electromagnet. Electromagnets can be used for many purposes. Some of the electromagnets are used as in the electric appliances like electric bell, electric fan, mixer, and washing machine. Electromagnets are used to separate magnetic materials like iron from metal scrap. Doctors use electromagnet to remove tiny iron particles which may have fallen into person's eye accidentally. Now let us discuss about working of an electric bell. An electric bell is one of the most common applications of electromagnet. It consists of an electromagnet, an iron strip, a screw, a hammer, a gong, and switch. You see, it consists of an electromagnet. This is the electromagnet. An iron strip. This is the iron strip. A screw, a hammer, a gong, and switch. Construction of an electric bell. An electric bell is a simple device which has a soft iron core with copper wire. This is the soft iron core over which copper wire is wounded. One of the end of the copper wire is connected to the switch. This is the one end of the copper wire which is connected to the switch, and another end of the copper wire is connected to the hammer. The hammer is connected to the screw. You see, this is the hammer which is connected to the screw. Now, working of electric bell. When you press the switch of the bell, electric current flows into the electromagnet. This is the switch. When the switch is closed, at that time the electric current starts flowing through the circuit and the current flows through the electromagnet. When the electric current passes through the electromagnet, it behaves like a magnet and attracts the iron stripe towards it. And when the iron strip gets attracted towards the screw which is attached with the hammer hits the gong and produces ringing sound. When the iron stripe has moved to the electromagnet, it no longer touches the screw and the circuit breaks. The electromagnet now turns off and no longer attracts the iron stripe. The iron stripe thus returns to its initial position, touching the screw again. This makes the circuit complete and the current flows again. So due to this, electromagnet again develops a magnetic field. The iron stripe is attracted and the hammer hits the gong again. All the above steps are repeated in a quick succession as long as you keep switch pressed. This makes the bell ringing continuously. Now let us discuss about electric current. The flow of electric charge constitutes electric current, and the path through which it moves is called the electric circuit. The direction of flow of current is opposite to the direction of flow of negative charge in an electric circuit. The magnitude of electric current is measured by an instrument called ammeter. So this is the figure of a simple circuit you see. It is a battery, and this is the connecting wire which gets connected with an electric bulb. When the two wires are connected with the two ends of the battery, electric current starts flowing. The electron starts flowing through the conductor and in a definite direction and forms the electric current. Now we discuss about electric cell. Electric cell or dry cell are the sources of electric current. They are used in torches, transistor, calculators. All the electrical cells which have two terminals, a positive and negative. If you look at a cell carefully, you will observe that it has a metal cap at one end. You see, there is a metal cap at one end, means at the positive terminal, and there is a metal disc. This is the negative terminal. Chemicals such as manganese dioxide, ammonium chloride, and carbon are stored in the cell in the paste form. The chemicals get used up, and thus the chemical energy of the cell gets converted into electrical energy. In this way, chemicals stored inside this cell generated electricity. When the chemicals get used up completely, the cell stops working and is said to be dead. If the tip of the metal cap and the base of the metal disc are connected by a wire, electric current flows. Electric current flows in the direction opposite to that of charge. The negative charge flows from the negative end to the positive end of the battery, while the current flows from the positive to the negative terminal of the battery. Many devices require more than one cell to operate. For example, a TV remote requires more than one cell to operate. The combination of more than one cell is called battery. In battery, negative terminal of one cell is connected to the positive terminal of the next cell in the form of a series circuit. You see, when a group of cells combine together, it forms a battery. And the cells are connected in series. It means that positive terminal of one cell is connected with the negative terminal of another cell. Such kind of combination is called series combination of cells, and the series combination of cells, a group of cells combined in series, forms a battery. Now resistors. Resistors are the materials that resist the flow of current. They do not stop the current, nor do they allow it to pass through them freely. So a perfect example of resistor is the coil in a toaster. The speed of the electric current slows down when the current flows through the coil, as the coil resists the flow of current. In simple words, the current will have to work harder to flow through the coil. As the current works harder, heat is generated in the coil. This heat is used to make toasts. Symbolic representation of electrical components. Electrical circuit is a path that which allows the charges to travel. The different components of electric circuits are wire, cell, bulbs, etc. In order to study the electric circuits, we need to draw the electrical circuit on a paper. It is difficult to draw the actual component of a circuit, thus we draw a simple representation of the circuit. This simple representation of a circuit is called circuit diagram. The different components of the circuit are represented in a circuit diagram using different symbols. Some electrical components, their uses and their symbols are here. Symbol of cell. Cell is the source of electric current. This is the symbol of open key and symbol of closed key used for operating circuit. This is the symbol of a circuit. Connect the component of circuit together. This is the symbol of a wire which connect the component of circuit together. Glowing bulb when the switch is on, and this is the bulb when the switch is off. Symbol of resistor. Resist the flow of current. Now we discuss our series and parallel circuits. We already know that electric circuit is a path that allows the current to flow through it. Based on the arrangement of components, electrical circuits are of two types. One is a series circuit and another one is parallel circuit. First we discuss about series circuit. In series circuit, all the components of the circuit are connected in a loop, in one loop. Means there is only one direction for the flow of current. You see there are two bulbs, bulb 1 and bulb 2 are connected in series. In the series circuit, there is only one path around the conductor. You see, there is only one path around the circuit for the flow of electric current, and the entire amount of electricity flows through the components in the circuit. Besides bulbs, other components can be connected in series too. Parallel circuit. This is the parallel circuit. You see, in a parallel circuit, the components of the circuit are connected in two or more loops. You see, here two bulbs are connected in parallel. There are two loops for the flow of current. In the parallel circuit, there are always junction. You see, it is a junction. This is also junction, and at the junction, the electric current leaves the battery where the current go along two or more different routes. This is route 1. In route 1, bulb 1 is connected, and this is route 2. In route 2, bulb 2 is connected with the circuit. The electric current leaves the battery from the positive terminal, and when it reaches the junction, it splits off. You see, when the current passes through the circuit and reaches the junction, it splits into two paths. One is path R1 and path R2. When the current reaches the another junction, it join together again and travel back to the battery. Good and bad conductor. Substances which allow electric current to pass through them almost freely. Such substances are called good conductor of electricity. For example, metal. Almost all the metals are good conductor of electricity. Some examples are copper, iron, aluminium, silver. Electric cables made of copper is, as it is, a good conductor of electricity. And on the other hand, some substances which do not allow electric current to pass through them, such kind of substances are called bad conductor of electricity or insulator. Some examples of insulators are wood, plastic, distilled water, quartz, bakelite, etc. Electric switches are made of bakelite as it is an insulating material and prevents you from getting an electric shock. For the same reason, the outer covering of the electric cable are made of insulator such as rubber. So this is all about the chapter electricity and magnetism. And with this your chapter is completed. So thank you very much for watching this video.